we are going to start with the concept of isotopes. And I hope most of you already know about the concept of isotopes, right?
Yes, sir.
I've
Because you
heard of it.
already, yes, because most of you already studied in the chemistry, but for those who don't know about the isotopes, so basically about the isotopes, we can say that atoms of same element. So atoms of the same element, yes, with the same number of proton but different number of neutrons. With same proton number or number of protons plus different number of neutrons.
Drums.
And for example, already there are many isotopes. Examples of isotopes are on the screen. So you may take the reference from that. Okay. You can see the first one, the basic one, that is the hydrogen. Basically, normally hydrogen contains one proton and one neutron. Okay, but in the second state, you can see that is known as deuterium. So in which you only have one proton but different number of neutrons. Same goes for the isotopes of oxygen, oxygen 16, oxygen 17, oxygen 18, right? Plus, there is also an example of the natural isotopes of carbon. So you can see in the carbon also that the first isotope is related to carbon 12. And in carbon 12, there are 6 number of proton and 6 number of neutron. Then after that, we have carbon 13, carbon 14, and for another element, there is an example of uranium. So there are multiple examples of isotope, but we don't need to memorize all the isotopes. You just need to know about the concept, because usually they ask about the definition of the isotope, plus they also ask that identify the number of proton or number of neutron from the given diagram or from the given example. Okay.
Sir, I have a question.
Yes.
Do the isotopes have to be naturally reoccurring in nature, or can we create them ourselves?
A
Uh,
good question.
yes, basically most of them are naturally available, right? Just like if we consider the example of oxygen and uranium and carbon, because uranium,
Uranium 235.
yes, because uranium mostly used for the nuclear power plants, and that was not easily or very commonly available. So these are natural elements, right? Because these all are the discoveries, because these all elements can be found in the periodic table. They have some different properties, slightly different property, just like they have different number of neutrons. Okay, so those are naturally available. Okay, because we are talking about atom, in definition you can say that atoms of the same element. Okay, so if you make them, so definitely that will be a mixture of them, that will known as compound. Okay,
Understood, sir.
so that is the concept. And the next topic of this chapter is very, very much important, because that is the most important section from the nuclear physics, and that is the most interesting part of it. So that topic is related to radioactivity. Okay, basically, radioactivity, the concept of radioactivity is related to the radioactive radiations, right? We already discussed about the concept of radiation in the thermal physics section. So you know that what are the properties of radiations? They don't require any medium, and there is also any special effect of radiation that we also discuss in the definition and in the concept of the radioactivity. So first of all, if we just explain the basic idea of radioactivity, so we can explain it like this: the phenomenon of emission of radioactive radiations from the nucleus of an atom. So basically, these radiations are coming out from the nucleus of an atom. And the main, first of all, we in this chapter we studied about the structure of atom, right? So you all know about the structure of atom, right? So basically, if we are talking about the nucleus of an atom, so there are multiple atoms, there are million billions of atoms in our surrounding, right? In our daily life also. So why there will be no radiations, or why there will be no effect of radiation in our daily life? Because there are multiple atoms in our surrounding, and we are not able to feel, or we are not able to observe that effect of radiation. So what do you think?
Wait, sir, can you repeat?
Question is, according to the definition of radioactivity, it is the emission of radiation or radioactive radiation from the nucleus of an atom. And we already studied the structure of an atom. So if we talk about the structure of an atom, so why we are not able to observe, or we are not able to observe that effect of radiations in our daily life? Because we are already surrounded by a million or thousands of atoms. So why we are
Because
not able?
it's electron radiation, right? And gamma rays.
Yeah, gamma.
Gamma rays,
It's like
okay.
a wave.
The
Okay.
wavelength is too
Okay.
small or too big. I don't remember.
Okay. So basically, the gamma, electron, all these concepts are like categories of radiation. But if we consider the atom, right? So in atom, we are having a nucleus. So why we are not able to observe that radiations? Because radiation only occurs in a specific type of element, right? Not all type of element, only in a specific type of element. Okay. And what are those elements?
Good
So
question,
basically,
sir.
yes. So this is the question, because there are multiple elements, multiple atoms in periodic table. There are different elements. So which elements are radioactive elements? This is the main question.
Uranium 235,
Yes, because
Uranium,
if
deuterium.
if all
carbon 14.
yes, if all elements are radioactive, right? So it means that we are always surrounded by radioactive radiations, and we know that those radiations are harmful. So it means that not all elements contains radioactive radiation, only a specific type of elements contains that radiation. So we have to study and we have to know about those elements. What are those elements that actually radiates, or that actually emits these radioactive radiations, right?
What about heavy metals? Can they also be like radioactive?
Heavy metals, basically in simple, because you already observe complete periodic table, right? Because that is all
Yeah.
given in the chemistry paper also, and you mostly studied about the periodic table in chemistry. So if you just check out the periodic table, so in the periodic table, all elements beyond lead in symbol Pb in the periodic table are naturally radioactive, right? So this is the very simple way to identify that which elements are radioactive and which elements are not radioactive from the periodic table. So you can just simply count the number of elements, or you just simply observe the number of elements beyond the lead in the periodic table, right? And further, if we discuss about one more important property, and that important property is that the radioactive emission or the radioactive process is random. So basically, what is the meaning of the random over here? So the idea or the concept behind the word random in this periodic table, so we can say that the emission do not occur in any pattern because in your exam they specifically ask about to explain the term random and spontaneous. So the meaning of word random in radioactivity is the emission do not occur in any specific pattern, right? So any nucleus can decay anytime. So there will be no specific timing, there will be no specific pattern, no specific rate. So any nucleus can decay at any time.
Right.
So any nucleus decay at any time. Okay, so this is the concept of random. Okay, any confusion? And there is another specific term related to the radioactive process, and that term is known as spontaneous. So the meaning of spontaneous is the process happens on its own. So basically nothing will be responsible for this radioactive emission. This can be happen by its own. There is no effect external conditions. And external condition means the temperature and the pressure of the atmosphere, because in the previous factors in the previous chapters we discuss about the factor affecting different quantities, right? But radioactive cannot be affected by any change in temperature, pressure, or anything in the atmosphere, right? Because it is a natural process, it happens by its own, and it may decay at any time. There is no specific pattern and there will be no effect of external condition. Okay, because if it is affected by external conditions, so definitely there will be some pattern of this process. Okay, and
Sir, I have a question.
yes,
Um, when a country builds nuclear bombs, how do they do it with uranium? Because its
mm,
radioactivity would harm them, right? Or plutonium.
yes. So basic
Hazmat suits.
yes, basically we are going to discuss all these things in this chapter, because we are going to discuss about the types of radiations, their advantages, disadvantages, how to prevent them, because all these topics, all these important points are included in your syllabus. So we will discuss that, right? So don't worry about that. We will discuss all these things one by one. Okay.
Okay.
We will also discuss that how atom bomb actually works, what is the science behind it. So we will complete discuss detail about all the atomic properties and the radiations. But before that, we have to identify three different types, as you already mentioned about the beta particle, alpha particle, and the gamma rays. So the first type is known as alpha rays. Second type is known as the beta rays. And third one, the gamma. So the starting two types of rays exist in the form of particle. So you can also write alpha particle and beta particle, right? Because these two types of radiations are available in form of particles. But for gamma, this is the only ray that is available in form of energy. Right? Any confusion?
No, sir.
So there are three types of radiation. And one more important question, if you think that one element can only emit one type of radiation, so it is not compulsory, right? Single substance can emit one or more than one radiation simultaneously, right? Like if you consider any unknown element Y, so that unknown element Y emits, either they emit only alpha or gamma, beta or gamma, any combination will be possible. So it is not compulsory that single element can emit only one type of radiation, right?
Right.
So I will also write it over here. So we can say that single substance can emit either one or more than one radiations simultaneously. Okay, any confusion? And for example, if we consider few elements, just for the example, you don't need to memorize the name of them and the radiation that is coming out from those particles. If we consider the example of radon, so radon is the radioactive element and it only emits alpha. So radon only emits alpha, and further if we write down the type of radiation for thorium. So thorium is another element that emits alpha and gamma. Right? And the third one is plutonium. So all three types of radiations can be emitted from the plutonium material, right? Plutonium element. So it depends upon the element. It is not compulsory that specifically one element can only emit one type of radiation. One element can emit multiple radiation or single radiation or any combination of radiation anytime. There will be no specific pattern of it, right? So any confusion in the basic structure, basic idea about the radioactivity?
No, sir.
Okay.
Sir, do we need to know which elements, what do you call it, radiate, what type of particles?
No, you just need to know about the sequence if they ask. Normally, they don't ask about the elements because those are already given in the periodic table. So you don't need to memorize all the elements. You just need to know that elements beyond lead, all elements are known as the radioactive elements. And the reason is that all the elements or the nucleus of those elements are unstable. We will also discuss that
Oh, okay.
of instability in the topic of half-life. Half-life also included in this chapter. So in that topic, we will discuss that why those elements emits the radiation. What is the reason behind that? The simple reason is due to the instability of the nucleus. And why that will be unstable? So that is the concept for the half-life. Okay. And before that, we have to discuss about the properties of alpha, beta, and gamma. Okay. Because there are three types of radiation, so they categorize them. So definitely there will be some difference. There will be some special properties of alpha, beta, and gamma that we have to know about. So if we start talking about their properties and their structure, their symbol. So the first column is for their properties. And there are three different elements: alpha, beta, and gamma. So the first property that we have to discuss is the nature. Because we only know about the name, that alpha particle, beta, gamma, but the question is, uh, what is the property or what is the nature or what is the actual type of alpha? What is the form of alpha that it exists in the form of nuclear radiations? So basically, alpha is completely, you can say that it completely looks like the helium nucleus, right? What is the atomic number and atomic mass of helium atom?
Wait, so can you repeat?
Basically, the nature of alpha is simply looks like the helium nucleus, right?
Yeah, so two protons and then four neutrons.
Yes.
No, sorry, two protons, two neutrons. Yeah.
So alpha completely looks like helium nucleus. So you can also say that alpha radiations are completely have the same nature just like the helium nucleus. There are two protons and two neutrons. And if we talk about the beta, so basically beta are fast moving electrons.
fast moving electrons. Okay.
Yes. So basically that gives you the concept that they are moving with high speed, not like the normal motion or the very normal speed, just like the revolution or the rotation of the electrons around the nucleus. Okay. Okay, so alpha particles are completely look like the helium nucleus, right? And beta particles are fast moving electron. And we already discussed that gamma only exists in the energy form, so it is not the particle. Gamma rays are only the high frequency electromagnetic radiation. So the frequencies of the gamma rays are very much high because those are electromagnetic radiations. In normal light or in normal radiations, the wave frequency of those radiations are not much very high. But if you are moving towards the radioactive elements or radioactive radiations, so frequency will automatically increase with their radiation rate. So these are also electromagnetic radiation. And the next property is related to the basic symbol and the nuclear symbol. So the symbol for alpha is look like that sign of directly proportional, right? So this is the sign for alpha particle. Or you can also write in the nuclear symbol form with proper atomic number and atomic mass, just looks like this, alpha 24. Okay. So if you want to write the normal symbol, so you just draw the directly proportional sign for alpha, it looks like that. And if you want to write the nuclear symbol, so also note down the number of proton and number of neutron with it. And beta are fast moving electrons. So this is the symbol for beta, or you can also write beta with 0, -1. Okay. And for gamma, this is the symbol for gamma. Okay. Any confusion? Further, if we talk about the properties, so we have to know about the charges of these elements or these radiations. So the charge for alpha will be the positive, that is +2, because there are two protons. And for beta, it will be -1. And what will be the charge of gamma? Because alpha are positive like helium nucleus, so that's why its charge is equals to +2. And for beta, the charge will be equals to -1. And what about gamma? Because gamma are only the frequencies or only the type of energy. So what will be the charge of gamma? Any idea? So basically, the charge of the gamma is equals to 0, because gamma is simply a frequency or it is only a type of energy. Okay, so there will be no charge of gamma. And further, if we talk about the properties, so their next property is related to their penetration power and their ionization power.
I think alpha are the least penetrating, beta are in the middle, and then gamma are the most penetrating, right?
So if we talk about the concept of the penetration power, so you can easily compare their sizes. So the size of alpha is greater than beta and gamma because you can easily identify by the number of protons and by number of neutrons. So basically alpha is a complete helium nucleus, so that's why it is not able to penetrate through uh, the other objects. It can be stopped by a very thin layer of a paper sheet. So that's why the penetration power of alpha is the least among beta and gamma. Okay. So the penetration power of alpha is the least one. And what is the reason? It is due to large size, and it can be stopped by
Wait, alpha is least?
the penetration power of alpha is least. It is
Oh,
just like a simple example. If you take the example of a tennis ball and the bullet, so basically it depends upon the size. Okay. Just like the example of the fork and the thumb pin that we discuss in the pressure, because the pressure on the thumb pin is the greatest, because you know the surface area of the thumb pin is like negligible, so it can easily penetrate, right? If you use a greater area, so it will be difficult to penetrate into the objects. So that's why the alpha particles, or you can see that the penetration power of alpha particle is least due to the large size, and it can be stopped by a piece of paper. And if we talk about the beta particles, so beta particles are more penetrating.
so like it's in the middle.
Yes. So beta is look like the moderate penetrating power as compared to alpha and gamma. So penetration power is greater than alpha due to smaller size, and it can be stopped by 1 centimeter to about 2 centimeter thick aluminium sheet, right? And if we talk about the gamma, so the penetration power of the gamma is the highest among alpha, beta, and gamma. So it contains the most penetrating power because it is only a wave, right? It is not a particle nature. So that's why the penetration power of gamma is greater than alpha and beta. So gamma contains the most penetrating power as it is a wave, and it can be stopped by about 4 centimeter thick lead block. Okay, one important point, if you notice that we are using lead to stop the gamma radiations, because beyond the lead, all the elements are radioactive. So lead is the last material or the last element, we can say that, which is the most stable in the periodic table. So that's why we are using the lead to stop the highest radiation or the highest frequency of radiation that is coming out from the gamma rays, right? And these numbers like 1 centimeter, 2 centimeter, 4 centimeter, these numbers are just for reference, right? Because sometimes in question, they ask you that this range of paper, thickness of paper or sheet or aluminum sheet or lead block is given. So you need to identify that which element can penetrate through it or which radiation cannot penetrate through it, right? So we will discuss that in the past papers question. So this is just for your reference. Okay. And further, if we talk about their further properties, so the next concept is related to their range. So the range of the alpha particle is about a few centimeter, like 4 to 5 centimeter. So it can only move through a few centimeters, approximately 4 to 5 centimeter maximum. And if we talk about the beta, so beta particles can move through few meters, 1 to 2 meter maximum. And for gamma, it can easily move through several meters, right? Any confusion?
No, sir.
And further, if we compare their speeds, so if we talk about their speeds, so the speed of the alpha particles are close to any value which is like 10 to the power 6 meter per second. And if we talk about the speed of the beta particles, because beta particles are fast moving electrons, so their speed is almost close to the speed of the light. So it means that their value is less than, or we can say that less than 3 into 10 to the power 8 meter per second. Any guess about the gamma rays?
It's the speed of light, right?
Speed of light, because those are already electromagnetic radiation, and all electromagnetic radiations moves with the speed of light, and the speed of light is 3 into 10 to the power 8 meter per second. One more property that is related to the ionizing power, and basically this ionizing power depends upon the charge of the particle basically. So you know that the ionization power, if you compare the ionization power, it actually depends upon the charge of the particle. So if you just compare the ionization power, so what do you think, which element or which radioactive radiations consists the most ionizing power, alpha, beta, or gamma? So what do you think that which radioactive element has the most most ionizing power, alpha, beta, or gamma?
What do you mean by
Penetrating power.
Ionizing
Gamma.
power.
Oh, ionizing. It's alpha.
Yes. So basically, ionizing power
Because it
actually
moves
depends
slower, so
upon
it
the
can
charge. Yes.
ionize the most.
So basically, the charge of the alpha particle is greatest among all the radiation. So that's why the ionizing power or the ionization power will be greater for the alpha. So the ionization power of the alpha is the highest, and it is due to its greatest charge. It absorbs electrons and turn into a helium atom. Clear? Any confusion?
No, sir.
And beta particle is less ionizing than alpha, and we know the reason, due to less charge. And finally, if we talk about the gamma, so what do you think? So there will be no
Yeah,
charge.
the least ionizing power.
no
The
ionizing
least.
power? None, because there is no
Oh, it's
charge.
none. Okay.
Okay, so basically, if you compare, because now we are in advanced technology, or if we use the micro or nano concept, so it is possible to like ionize those radiations also, right? Because there are different experiments on advanced level that used to be performed to ionize the radiations also. But if you compare the concept of alpha, beta, and gamma, so on gamma particle, there is no charge. So hence the ionizing power is the least one as compared to alpha and beta. Because we know that we can use experiments or the combination of different elements to ionize the particles, right? So that's why we just combine that gamma with some other particle like one neutron or any other particle to ionize or try to ionize that, right? But for single gamma, if we consider only gamma, so there will be no charge, so it will be not possible to ionize that simple concept of gamma, right? So hence there is no charge. So there will be least ionizing power if you want to ionize it with the help of some other particles. Okay. And let's suppose if you are performing this experiment, so let's suppose if there is a magnetic and electric field, right? And you are performing the experiment of the radioactivity, and there is a strong magnetic and electric field. So what do you think that alpha, beta, gamma, which radiation will affect by the magnetic and electric field? Any idea? Which type of radiation uh, just reflects from the electric and magnetic field?
I think it's alpha, beta,
Yes, because
and gamma
alpha,
won't
beta,
because it has no charge.
yes. So those radiations which contains the charge on it, so that can be deflected by the magnetic field and electric field also, right? So if we consider the magnetic and electric field, so let's suppose
Wait,
if
so which one deflects more? Is it beta or alpha?
the beta.
Yeah, yeah, okay.
So if we consider a magnetic field, and we are having three types of radiation coming out. So let's suppose I'm not marking the exact diagram of magnetic field because we are just talking about the basic property that which element or which radiation is going to be deflect or what will be the angle. So alpha will deflect like this. So you can just compare their deflection angles. This is for alpha and the central one is for, so the top side or the top radiation is for alpha. This one is for gamma and this one is for beta. Okay. Basically, you know that alpha particles are heavy, right? So it takes time to deflect alpha particle. But beta particles are the fast moving electrons, so the mass of the electrons are less as compared to the alpha particles. So that's why the deflection angle of beta is greater. And if we consider the gamma, so gamma has no charge on it, so definitely it will move without any deflection. And the second concept of electric field, so basically, if you consider the electric field, so let's suppose we are having positive charge on left hand side, negative charge on right hand side. Okay. So if we start marking the deflection of alpha, beta, and gamma, so you can easily identify if we talk about the alpha particles, in which direction alpha will deflect
Towards negatively charged
towards
plate
negatively
side.
charged particles. Sorry, towards negatively charged plate, and for beta, beta will deflect towards positive charge plate. And also keep in your mind that beta deflects more as compared to alpha. So always there is a difference between the deflection angle of alpha and beta. Like first of all, if we draw the gamma, so gamma moves in a straight direction like this. So this is for gamma. And second, if we talk about the alpha, so alpha will move like this with a short angle, and beta will move like this with a very large deflecting angle. Okay. So you can easily identify that beta deflects quickly. This is for gamma, this is for alpha.
Sir, I understood the electric field one, but I didn't understand the magnetic field one.
Basically, for magnetic field, we have to study the whole concept of electromagnetism, right? So that's why I only just give you the deflection rate. Okay.
Okay.
So that's why I only just showed you the deflection. Okay, not the complete magnetic field, because for a magnetic field we have to study the complete idea about electromagnetism, but for the time being it is not compulsory to study the whole theory then to apply on this. Okay, so that's why you need to keep in your mind that these two will deflect in magnetic and electric field, and the angle of magnetic and the angle between the alpha and beta is completely different. They will not deflect with the same angle. They definitely deflect with a very different angle because of their mass and because of their charge. Okay,
Okay. Okay.
so this is the concept related to alpha, beta, and gamma particles, right? Sorry, gamma rays, alpha and beta particles.